Good evening, everyone. Good evening. Okay, so let's start. There are few fill in the blanks questions. Okay, so for I'm writing all the questions. Okay, then we'll be discussing it one by one. A point is that which has a dash is a dash is line which lies evenly Next one is a surface is that which has dash and dash only. The edges of a surface are dash. Okay, let's do it. 5 fill in the blanks question is there. Just a moment. What will be there in the first blank? A point is that which has no what?
Part.
Part.
Everyone, is it part?
Part. Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Yes. A point is that which has no part. Part means it has no dimension. Okay. We have understood this statement when we were going through the definitions, few definitions given by the Euclids in our book. Now the next one, a dash is a breathless length. What is the breathless?
Line.
A line.
Line.
Okay, a line is a breathless length, or a straight line. A line is there is no breath, only length is there. What about the next one?
A straight line.
Yes, I want answer from each and everyone. Arhan.
A straight line.
Straight line. Straight line.
Straight line.
Other. Samya, Sarah.
Ma'am, a straight line.
Straight line, right? Yes, please on the camera. Yes, please on the camera. Yes. Bharti, Samya, Arhan, Shad, Heather, Sarah, Anam. Okay. Now the next one. A surface is that which has dash and dash.
Length and breadth.
Yes, Bharti.
Length and breadth.
Yes. Rest of the student. Arhan, Anam, Hanan, Samya,
My length and breadth.
Sarah.
Length and breadth.
Length and breadth. Yes, it will be length and breadth. Okay, a surface is that which has length and breadth. We have seen the surface, we have discussed it in detail. That surface has just length and breadth. Now the next one, the edges of a surface are what?
Line.
Exactly. Surface is completely made up of line. Okay, edges are also line, and yes, it is line. Any confusion? Anyone having any confusion over here? What exactly all of a sudden we are writing? Anyone not getting? Please let me know. Clear. Okay, let's do a few true false questions. This is true false question. If equals are subtracted, let me write all of it, then we will be discussing it. Because this chapter is like that only. Theories are there. Okay, and this type of fill in the blanks, true false question. Just a moment, no? Now the question is if equal are subtracted from equals, are equal. Next is things which coincide with one another are equal to one another. Next is the whole is less than a part. Next is things which are double of the same thing are equal to one another. Next is things which are half of the same thing are equal to one another. Let's see what exactly is there. First one, okay, I'm reading it. We need to read the statement carefully, then we will decide whether the given statement is true or false, okay? So if equals are subtracted from equal, the remainder are equal. Is it true?
Yes, ma'am. True.
Yes, ma'am. True.
Yes, ma'am.
Is it true?
Yes.
Yes, it is true. Okay, if already two things are equal and you are subtracting equal from both of them, then the remainder, the remaining part will be equal. Yes, the statement is true. Next one, things which coincide with one another are equal to one another. Is it so?
True, ma'am.
Yes.
True.
Read it carefully.
And
Things
true.
which coincide with one another are equal to one another.
And
True,
true.
ma'am.
What is the meaning of coinciding? What is the meaning of coinciding?
Overlapping.
Vote for it. To true or false? Who is going to say true? Who is going to say false?
True, ma'am.
Yes.
And true.
Saad?
And true.
Okay. Who said true? Bharti is saying true. And who else? Samya is also saying true. Yes, who else said
Ma'am,
true?
ma'am.
Ma'am, true.
Heather is also saying it's true.
True, ma'am.
Yes, who said false? Arhan said false, right, Arhan?
No, ma'am.
What you said?
I'm
Arhan?
true.
Vote for false and true. Okay, I am seeing all the true, true, true. Who is going to say false? We will be checking it after a while. First, tell me true or false. Vote for it. Vote for true. Vote for false.
Am I
Anyone?
audible?
Sarah, which one? True or false?
Ma'am, true.
It's true. Okay. Muhammad Rafi.
True.
True. Arhan is also saying true. Saad,
True.
is it true? Is it so? Let's check it. Things which coincide with one another. The example I was showing you previous day. Just a moment. If two things are there, if I am taking two pages, and if it will cover each other completely, then these two are exactly same. That's what the question says. Coincide means what? It will just, one is going to lie on the other one. That's called coincide. And cover completely. Coincide means covering completely. If that is the case, then both are equal. Yes. If that is the case, both are equal only. We know that. It is true. Any confusion over here?
No,
It is true.
No.
Next one. The whole is less than a part. Vote for true, vote for false.
False. False.
Everyone, is it false?
Yes.
Exactly.
Yes.
It is false. Whole is less than part. Whole pizza you are having, part of the pizza someone is having, you are having less than that person? No, it is false. Okay, previous day we were talking about this. Next one, things which are double of the same thing are equal to one another. Is it so?
True.
Is it so?
True.
Yes, and true.
True. True.
Yes. It's true. Yes, it's true. Things which are double of the same thing. Two things are there which are double of the same thing. Okay, we were taking X and Y two things are there, and there is a thing k. So x is also 2k, y is also 2k. So both are equals to each other. Yes, both are equals to each other. Next one. Things which are half of the same thing are equal to one another. True or false?
True.
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 Okay. Perfect. Now the next one MCQ question is there. Number 1. Lines are parallel if they do not intersect. Is stated in the form of number 1, option A, an axiom, a definition, a postulate, postulate we have not, still we have not learned. Okay. Option D, a proof. Any idea? Option? Which option is the correct option? Anyone?
Option A. An axiom.
Okay, Arhan is saying option A. Is it so? When we were discussing the axiom, we have discussed something about parallel lines.
A definition.
C.
Who said a C?
Me, teacher.
Okay. Who said B? Samya, you said?
No, ma'am. No, I'm saying option A.
Okay, you are saying option A. Who said B?
Hanan.
Hanan, you are saying?
Yes.
Okay. Okay, I can see students are giving mixed like opinion. Few students are saying it's A, few are saying it's B. Someone said it's C. Heather B. See, if you can't see the statement, I am just showing it over here. Think about it. Have we discussed this statement while discussing the axioms or axiom given by the Euclids? It is not an axiom, okay? We have not discussed it while discussing the axiom. Recall it. When we started the discussion of axiom, we started the discussion with if two things are already same. If we are adding same on both sides, the result is same. If two things are already same, if we are subtracting same from both sides, the result is again same. Okay? If two things are there which is double of the same thing, the result is same. If two things are there which is half of the same thing, the result are same. Okay, if two things coincide with each other, then both are equal. This is what we have discussed in axioms, but about line we have not discussed in axiom. Okay, so our option A is not the correct option. Getting it? Everyone having book? Are you having book in front of you?
Yes, ma'am.
Open
Yes,
the book.
ma'am.
Open the book, open this chapter, Introduction to Euclid's Geometry. Open the axioms, the series of axioms over there. Is it there?
Yes, ma'am.
Go through the axiom. Is this statement is written over there? Lines are parallel if they do not intersect. Lines are parallel if they do not intersect. Is it there?
No.
It's not there, right? That means it's not an axiom. However, all the axiom of Euclid is not there. Okay, we are having few axiom in your book. Few axiom of Euclid is there. Okay, and the sequence is also not maintained. Then also in few question you will find that it is talking about axiom 1. It is talking about axiom 2. Okay, so I said to you that we will be learning the postulate number by number. That is number 1 postulate, number 2 postulate, number 3 postulate. Axiom, here also axioms are not given the sequence fully, but in few question you will find that it is just written over there. Axiom 5 says this, yes or no, and what. So when you are going to learn the axiom, no, please learn it sequentially, so that if teacher will try to make the question tricky, you will not get stuck. Okay, learn it in a sequence manner, like axiom 1, axiom 2, axiom 3, axiom 4, axiom 5, like that. Okay, now this is statement. Euclid has given the definition of a point, definition of a line, definition of a surface, definition of a solid shape, definition of parallel line, definition of perpendicular line. I was talking about that in the previous class. Yes or no? Euclid has given us all the geometrical definitions. Okay, so it is nothing but just a definition. However, in detail, it's nowhere it is written in your book, and you will feel that you have not learned this concept. Okay, this line was not even there while talking about the definition, while talking about the axiom. But yes, this concept, the definition of perpendicular line, parallel line, these all the definition is given to us by Euclid only. These are just the definition of the parallel line. Okay, it's not a postulate, it's not a proof, it's just a definition. Getting it? Instead of parallel line, if perpendicular line definition will be there, please say them. Getting it?
Yes, ma'am.
Yes, ma'am.
Getting it?
Yes, ma'am.
Okay, so these type of question will come from this chapter. And apart from that, let me take one question where we have to prove something. Just a moment. Just a second. Now the next question is, in the given figure, if AD is equals to BC, prove that AC is equals to BD. Let me draw the figure over here. A, B, C, D. In this figure, AD is equals to BC. Yeah, AD is equals to BC. We have to prove that AC is equals to BD. How can we do so?
By using third axiom.
By using which axiom?
Third.
You said Samya?
Yes, ma'am.
Okay, Samya is saying third axiom. Not sure. Rest of the student, please give your opinion first. How can we prove it? You are having axiom in front of you. The question is already there in front of you. How to prove that? If AD and BC is given as the same, we have to prove that AC is equals to BD. Okay, think about it. Meanwhile, let me take out the other question which we can discuss today. Then only we will move to postulate. Yes, anyone? Third axiom. Okay, let's do it. Yes, third axiom. What is that third axiom? Can anyone say what's the third axiom? If
If the equal are subtracted from equal, the remainder is same.
if equal are subtracted from equal, the remaining are equal. Okay, if something is already equal and if you are subtracting the same term from both sides, the remaining will be equal. That's what the third axiom says. Okay, so here it is given that if this means it is given that AD is equals to BC, given that AD is equals to BC. Okay, now what we can do, we have to prove that AC is equals to BD. So from AD, what can be subtracted so that we will end up having AC? From AD, from this complete AD, what shall I subtract to get AC? Because we need AC. Yes.
CD. Ma'am, CD.
Okay, so from this AD and BC, which are already equal, can we subtract? Can we subtract? Can we subtract CD from both sides? If we will do so, what are we going to have? AD minus CD is AC. BC minus CD is what? See the figure, it is already there in front of you. See, BC minus CD is what? From this complete BC, if we will cut down this much part, cut it, what will be remaining?
BD.
BD, right? Right? So we are AD minus CD. From this much AD, if you will cut CD, you will be left with just AC. Okay? AD minus CD is AC and BC minus CD. See the figure, BC minus CD is BD. And we are done with the proof. Here we have to give the reason why we are subtracting CD from both sides. We have to write the axiom 3. Here we have to write axiom 3. If equal are subtracted from equal, the remaining is equal. Okay. Here we have to write axiom 3. If equal subtracted from equals, the remaining are equal. See axiom 3, you are already having book in front of you. See axiom 3, what is the statement? That only we have used. Let me summarize the concept. Here it was clearly given that in the figure AD is equals to BC. It is clearly given that I have written that it is given that AD is equals to BC. Now we have to prove that AC is equals to BD. Okay. So we are subtracting something from both the side. That is what CD we are subtracting. By looking at the figure, we realize that if we will cut down CD from the left hand side and from the right hand side also, we will end up getting the proof. It is that simple. Yes, it's that simple. You just have to be careful and you have to write the axiom properly. So learn the axiom. Have you learned the axioms?
Yes, ma'am.
Yes, rest of the student. Hanan, you have learned. Okay, Heather,
Yes, ma'am.
Bharti, Mohammad Rafi,
Yes,
Arhan, Sara, have you learned these axioms, the definitions? Yes, you need to memorize it. Okay. Postulate is also there. We will be discussing that. And that also you have to learn it in a sequence manner. Is this clear? How we done the proof? Now we will
Yes, ma'am.
say that we are done with the proof. Proved. Is it clear to everyone? Please let me know.
Yes, ma'am.
Clear. Let's move ahead. Now the next question I am giving to you, do it. If A, B, and C are 3 points on a line and B lies between A and C, then prove that I'm drawing the figure. Don't worry, I'm drawing the figure. Prove that AB plus BC is equals to AC. This is how we are having the figure and this is what we are having the question. Please try it. Okay, let me make the wide screen. Yeah, now I believe everything is visible. A is there on the line. Try it. Think about it and let me know how to do it.
Ma'am,
Yes.
ma'am, I got the answer.
Me too.
Yes, Anand, you said.
No, ma'am, Sarah.
Okay, Samya, you said.
No, ma'am, Sarah.
Okay, Sarah, you said. Okay. I have to see here that who has unmuted themselves. Okay, Sarah. You got the answer. What you got, Sarah?
Ma'am, we can use the fourth axiom because AC is coinciding AB and BC.
Okay. Fourth axiom that says things which coincide with each other
Coincide with
are
one
equal
another.
to. Okay. Okay, rest of the student, please check. Sarah has already responded. Who else was trying to respond? Yes, Arhan, you wanted to say anything? Saad? Heather? Please check it how to do this one. Which axiom will be helpful to prove this? Okay. Yes. Have you done that? Yes, Bharti. Do you want to say anything? Axiom 4. Okay.
And by using axiom 4.
Yes. Rest of the student, Mohammad Rafi, Samia, you said axiom 4. Saad, axiom 4. Let's see how axiom 4 is going to help us. Okay. So if A, B, C are 3 point, we can say A, B, C are 3 point on a line and B lies between A and C. Between doesn't mean that exactly in between. Okay. Anywhere between. Okay. A and C, then prove that AB plus BC is equals to AC. This is so obvious. AB plus BC is equals to AC. It looks like it is clear from the figure only. But we will not say that it is clear from the figure only. We will give a proper reason. That means we will paste a axiom while writing anything in this chapter, while proving anything. We will think about the axiom. We will think about the postulates. Okay. So here one axiom is there which will help us. The axiom says that when we will be taking AB plus BC will coincide with AC. Okay, AB plus BC when you will take, that will coincide, that will lie completely on the AC. Suppose you have taken the same measurement length, one AB you have taken. Okay, AB. The same measurement, whatever is AB over here, the same measurement you have taken AB. Okay, and then BC you have taken whatever measurement BC is there, be it 2 centimeter, 1 centimeter, 3 centimeter, whatever is there, you have taken one BC separately. Now your AB plus BC, when you will add both the line, it is going to completely cover this line AC. Yes or no?
Yes, ma'am.
Right? So this axiom will help us to prove that when we are going to take AB separately, BC separately, when we will add both of them, it is going to completely cover our straight line AC. That means going to coincide with AC. Okay, and hence things which coincide with each other are equal to each other. Hence, AB plus BC is equals to AC axiom. We will be writing proper reason we are giving, and then we are saying that hence proof is done. Anyone to whom it is not clear? Anyone? No. Let's do one more question. In the figure, I'm drawing the figure. AC is equals to XD. C is the midpoint. Let me make it wide so that we can cover the midpoint of AB, and D is the midpoint of XY using Euclid axiom. Show that AB is equals to XY. The figure is this one. Okay, this is the figure and this is the question. First try it, then we will be doing it together. Okay, do try this question. Yes, Bharti.
The first axiom.
First axiom. Okay.
Things which are equal to one another are.
Okay, Bharti is saying first axiom. That will help us to prove that. Rest of the student.
First axiom.
Okay, axiom 1. Arhan is also saying axiom 1. Check it. Is it so?
Axiom 1.
So the first axiom is things which are equal to the same thing are equal to each other, right? That's what the first axiom is. So how we will be writing? AC and XT we are going to write. Then after that, what step we are going to perform so that we can use the first axiom? Anyone, can you tell me? Whoever is saying first axiom, please tell me what will be the steps for that. Here it is given that AC is equals to XT. This AC is equals to XD. AC is equals to XD. And it is given that, it is also given that C is the midpoint of AB. C is the midpoint of AB and D is the midpoint of XY. Okay, we have to use Euclid's axiom to prove that AB is equals to XY. First axiom, if you are saying, then please tell me what will be the step, things which are equal to one another, like things which are equals to the same thing are equal to one another. Yes.
Then AB upon 2 is equal to XY upon 2.
AB upon 2 is equals to XY upon 2. Yes. Then
and AB is equal to XY.
Yes. Yes. From AC is equals to, just a second. From AC is equals to XD, and we know the C and D are midpoint. You are writing AB by 2. Since C is the midpoint, you are writing, what are you writing? Since C is the midpoint, we know BC and AC are same, right?
Yes, ma'am.
Directly, can we write AB by 2 is equals to XY by 2? Directly, like just after this step, can we write this? Are we using the given condition? The given condition we must use, no?
Yes, ma'am.
Anyone else? Yes, this reasoning is correct, that AB by 2 is equals to XY by 2, but the steps we are not able to write properly. The given information we are not able to use properly. The given information is AC. AC is equals to XD. This is the given information. Apart from that, one more given instruction is there. That is D is the midpoint of XY and C is the midpoint. C is the midpoint of this AB. Okay. So can we write if C is the midpoint of AB, can we write AC is equals to AB by 2? Can we write, since C is the midpoint?
Yes, ma'am.
Now, since D is the midpoint of XY, okay, D is the midpoint of XY, the complete lines XY, that's midpoint is D, okay? So can we write that XY is equals to XD by 2? Wait, no, not like that. XD is equals to XY by 2. XD half is equals to XY by 2. Can we write like this? Since D is the midpoint, this much is what? This much length is what? Half of the total. XD is what? Half of the total. Can we write like that? Since D is the midpoint, can we? See, if C is the midpoint of AB, if C is the midpoint, suppose we are having a line AB and C is the midpoint of that. That means BC, AC, both are same. Yes or no?
Yes, ma'am.
Okay. From here, can we write AC is half of total and BC is also half of total? Can we say? Can we?
Yes, ma'am.
Similarly,
Yes,
we are having one more line. The name of that line is XY. Okay. And here we are having D. So here also we can apply the same logic for the other line. D is the midpoint. It is clearly given. That means XD and DY both are same. We can write XD as a half of the total. And we can also write DY as a half of the total. Can we?
Yes, ma'am.
yes,
Okay.
yes.
Since here we are having the given condition is AC is equals to XD. The given condition is AC is equals to XD. So we can write it as half. AC means half of the total. AC means half of the total. AC means half of the total length of the line. What is the length of the line? It is AB. AC means AB by 2. Now we can write it. Okay. Whatever you said. Who said? Samya said?
Yes, ma'am.
Yes, Samya. Whatever you said, your reasoning is correct. This is how first we need to understand and then we will be writing. AC, we can write it as a half of the total. That means half of AB. This XD we can write as a half of the total. What is total? Total is XY. Half of that is XD. Yes or no?
Yes, sir.
Now both side by 2 is there, which will get cancelled out. Okay, if you will write over there AB is equals to XY by 2, and then this side's 2 you will just get multiply with other side, 2 and 2 gone. Yes or no?
Yes.
Now AB is equals to XY. We got it. Now which axiom we have applied? Read the last axiom. Read the last axiom.
Things which are halves of the same things are equal to one another.
Getting it?
Yes, ma'am.
Yes, sir.
Getting it? Things which are half of the same thing are equal to one another. Okay.
Yes, ma'am.
So this
Yes,
is
ma'am.
how we will be using the last axiom. Okay. Or we could also have used the double cases. The double means the previous, before that one more axiom is there, things which are double of the same thing. Let me take the scenario. A, B, C. Okay. X, Y. Yeah, X is the upper one. X, Y, here D. This is how we are having the line. The given information is AC is equals to 2x. AC is equals to XT. We can multiply 2 on the both side. We can multiply 2 on the both side. 2AC is equals to 2XT. Because in any equation, adding same number on both side is allowed. Multiplying same number on both side is allowed. Okay, dividing same number on both side is allowed. Subtracting same number on both side is allowed. So we are doing the multiplication of 2 on the both side. Now we can write 2 times AC means AB and 2 times XT means XY. Things which are double of the same thing is equals to each other. Getting it? Either that
Yes,
way
ma'am.
or this way.
Yes, ma'am.
Any confusion?
No, ma'am.
No.
Okay, so today also there is only one assessment which is based on Euclid's geometry. Okay, this complete chapter is a compact full one chapter is there, one topic is there, that is everything the is given by Euclid. Axiom, postulate, definition. Postulate, axiom, definition, axiom we have covered. Postulate is still we have not covered. We will be starting the discussion of postulate in the next class. Meanwhile, if I find any question from this axiom part, we'll be doing it together. If you get any question from the which is related to the axioms, please let me know. We will be doing that. Okay, otherwise we will be discussing the postulate.